Tonight's speaker is Steve Dittmar. I never thought I'd get to introduce a speaker as a cheesehead, but he is a self-proclaimed cheesehead from Green Bay, Wisconsin, which I assume means he's a Packers fan. However, Steve grew up appreciating the night sky in what he calls the real upstate New York. He's a software engineer by day and MHAA member and volunteer by evening, and an amateur astrophotographer by night. Steve has been enjoying astrophotography since 2014. He's just returned from his third year as an instructor at the Adirondack Sky Center and Observatory's astrophotography workshop. He is a frequent volunteer at MHA outreach events. Has created and manages the MHA website, and he is also a member of our steering committee. Tonight, Steve will do a complete walkthrough of the astronomy weather forecasting app, Astrospheric. It's available on laptop and phone versions, and it's loaded with great features. And best of all, Steve will also explain how MHA members can get free access to the pro features. And so with that, present Steve.
Thank you. I'll get my sharing going here. So yeah, astronomy-centric forecasts with Astrospheric. So Astrospheric is a real nifty app. It's also a website, so you can actually get these forecasts any way you like, whatever your preferred medium is. But for the most part, most people are going to be using their phones. So we're going to kind of focus on that. The screenshots I show will be using that interface. I think that'll be the most common for us. So what it does primarily is give you an option or give you lots of data to get localized weather information to help you plan and predict your night sky conditions, and particularly the conditions that are important for astronomy. It offers up to an 84-hour forecast, hour by hour, primarily using data from the Canadian Meteorological Center, which is updated frequently every 6 hours. So we use it in MHAA when we're determining whether we need to postpone or cancel an event, and I use it personally when I'm planning a lot of my astrophotography outings. So some of the information at a high level that it covers are forecasts and maps. You can favorite locations to make it easier to check out different spots that you're not living in at that moment. You can get weather alerts for those locations. It'll show you the ISS transits. You'll get solar system and DSO charting if you want to kind of plan out a little bit within the application when the different targets are going to be higher in the sky. And then there's also a subspace social forum, but it's got a myriad of other useful information as well. A lot of people ask, there's other applications out there. Some of them out there a little longer, like clear sky charts. So why Astrospheric versus clear sky charts? Some people have their favorites, and that's perfectly fine. Some models will work better for different locations than others, but they're not necessarily giving you the same information. It's not going to be, if you compare them directly, you're probably not going to get exactly the same results. And why is that? Well, Astrospheric processes raw model data, which is a higher resolution, and it does it 4 times a day. Clear sky charts actually processes a lower resolution of that data and only twice a day. Astrospheric will dynamically generate your forecast for your particular location. So whenever you move the location on the map and you tell it to give you a new forecast, it's drawing up new model forecasts at that moment. Whereas clear sky charts uses predefined locations. It'll pick the models that's already generated for the nearest location to whatever you pick. There's also constantly updating astronomy variables in the Astrospheric application. And some of the things I like about Astrospheric that are not in clear sky charts at all, at least that I've seen lately, that clear sky charts doesn't factor in smoke and aerosol data for transparency and doesn't evaluate the cloud movement trends in the area when it's making its models. So there's 3 different versions, different editions, as they call them. The free edition covers the good majority of the features, but it does display ads. So you don't have to pay for anything if you don't want to. Oops. $330 a year is the wrong number for Pro. It should be $29.99 a year, I believe. I think it's $30 a year. So ignore that little snafu on the slide there. That if you go pro, that gives you the access to all the features without the ads. Just to give you an idea of what the pro features are, and we'll go through all these, of course, in a moment. There's extended cloud layers. There's what they call an ensemble cloud layer, where they show multiple cloud layers over top of each other, so you can get an idea for which models agree on the clear skies in different areas. There's no limit to the number of favorites you can save. They'll include the smoke indication in the transparency bar of the forecast, remove the ads, et cetera, et cetera. There's other stuff as well. But there's a third version, which is interesting for us, called the Free Professional Society Edition. And in that one, you get all of the pro features that you would get if you were paying, but you get them for free, with the exception of just doesn't remove the ads, so you'll still have ads. And you don't have access to their API, which, unless you're a developer trying to put this on your website or something, that's not going to matter for 99% of the users. And it's free if you're in an astronomy association that meets certain criteria. And that has to do with hosting the Astrospheric website information on the club website, being active to some level on the Astrospheric social subspace account, and we meet those criteria. So the nice thing is, at the current cost per month of Astrospheric Pro, you could actually pay for and have some money left over the MHAA yearly dues that we charge. So we only charge $25-26 a year. Astrospheric Pro is about $30 a year. You can get that for free if you're a member of MHAA, and we can add you to it, and then you get those pro features included. So you can consider that as a nice perk out of for if you want to be a paid supporting member of MHAA. So admins like myself can give you a code to join the group in Astrospheric, and that's how you get access to that free society version. So reach out to me or to one of our officers in Slack, or if you want to email me, it's Steve at midhudsonastro.org, and I can send you the code to do it. I don't want to post it on here just because, foremost, I want to respect the developer, not abuse the generous offer of giving away the pro level of information to just the entire internet, so to speak. But I've seen he's constantly, making updates and that kind of thing. So I actually even pay for the pro level, even though I could get it for free. But I want to support him for continuing to do the good work. And I also think it makes sense to limit it as another perk of being a member of an actual society, because we are 100% nonprofit and don't have any sponsors and that kind of thing. So anyways, so if you get in contact with me, I can give you the code and show you where to put it in, and the website and the app rather, to access the pro level features for free. So let's just walk through the actual application. I'll start with how it looks when you first start up. You're not logged in yet or anything. It's just going to ask you for some basic permissions, GPS permissions, because it's using location to generate your charts. And then it uses notification permissions for weather's alerts and subspace group alerts. And then it just walks you through some basic, here's the basic concepts of the application. You can click through those. The important part is to click the sign in button in the top right corner, and you just provide your email address. And that's all you have to do to sign up, and they'll send you a link. And once you confirm through that link, you've kind of created an account with them, and that allows you to save your your favorites and that kind of stuff. In the free level, I believe you can save 5 favorite locations. It's unlimited when you're in the pro version or the free society pro version. So this is the main Astrospheric interface. The right side is their website, and the left side is the application in my phone. It's very data dense. There's very little empty space, and everything you see has a purpose and a meaning, which I actually kind of like, because I don't like having to scroll around and go through 10 different tabs and subpanels to find the information I want. But I realized that for some people, if they're not used to this, they weren't really sure how to read the data, or didn't know that certain data was even included, which is part of why I'm doing this presentation. And others didn't realize that they could even access the pro features for free. So real quick on subspace. So subspace, if I go, actually, let me go back 2 slides here. You see the S in the top right corner. That's the subspace icon. Sometimes I'll be making colors indicating that there's new content there you haven't seen yet. But when you tap on that S, or in the website, if you go to the subspace tab, that's how you access subspace. And then what's there are images and discussions and club and event information. So I go through and I post our stargazing parties on there as events so that other astronomers in this subspace forum can spot them if they're nearby. When you get the code from us, all you have to do is you go into that subspace and you have to click on join group, and then it'll ask you for the subspace code at the top. That's where you enter it and you hit transmit, and that'll automatically add you to the group. If you can just search through all the clubs, they're all alphabetical. You could find us in there and try and join from there. I have to then approve it, which means I got to go look you up in the database and see if you're a member or not, and that kind of thing. So it's a lot more expedient if you reach out to us for the code first. All right, so these are kind of the settings menus here. Move my bar away. So when you're in on the left side, I kind of did like a full scroll view of the application in the phone. You don't need to worry about necessarily making out what you see there. We're going to walk through all of this. But when you click on the settings hamburger menu icon in the top left corner, that pops up this settings view. Now within the settings view, you can see there's some basic stuff at the top for your maps, your favorites, subspace is another way to get to those. Documentation, if you need to figure out what anything means, they do have pretty good documentation about everything in the application. Basic settings for your preference for units and time, and then different information about what you actually want to see or not see. So for instance, if you don't want to see the ISS flyovers in the main screen there, you can actually say no, and it won't bother showing those to you. But you'll notice that some of these things say Pro on them. And the things that say Pro, such as the ensemble cloud models, let me get my little pointer up here. Where it shows Pro. Those items are what are only available if you have the Pro or the Free Society Pro edition. It's not available, it's just the regular free edition. So you get access to a couple additional cloud models, which is nice. The smoke in the transparency bar, which we'll show you in a bit, which I like that a lot. And then some mini map features about which, we'll go over that in a second too, but basically which maps are quickly available in the mini map view as like little quick icon links. So so this is just zooming in on that top half and the bottom half so you can kind of see more clearly on the screen here what's there. The data cards at the bottom of the last part there are the additional segments at the very end of the main view on the left here. When you scroll all the way to the bottom, it's just which order you want to see these things. You don't actually disable or enable them, it's just which order they're in. You can change. So if you want to see the moon details all the time, but you don't really care about the forecast details, you can throw that at the bottom. Just kind of make it so you don't have to scroll as far, whatever's important to you. Okay. So maps are one of the key features I have here. So the mini map is what they call the top view of the main window, the main application window. You can see there's a lot of information in here already. There's the menu and settings icon that we showed you before, the hamburger menu. But it also shows you the forecast coordinates. So whatever that cloud, map is showing you, that's for this particular coordinates. If you've got it saved as a favorite, it'll show the favorite name there instead. The magnifying glass is how you change location if you want to move it around. And if you want to pick a favorite, you go to the star. And if you want to enter subspace forms, you tap on the S. Now within the view, you've got the forecast time over here. So this is the cloud model for that day at exactly 10 a.m. on that Sunday. You've got a button that will animate the forecast showing the next several hours of how that cloud model is going to evolve. And then you've got these different icons within the map. So your current location for where this map is forecasting is the red, like reticle here. And then the blue and the green pins represent the community pins and your favorites in particular in that order. So I have Tupper Lake and Lake Taconic and my house in the Poughkeepsie area, are all three of the green ones. Those are all favorites on my list. So that's why there's three green green pins here. The blue pins are other club locations and things like that. And then the or sorry, not necessarily club locations, but locations that are pinned by the community members in subspace. The societies and clubs are represented by stars. So if you were to tap on any of those, it would give you information about those particular things, but focus on the map for the moment. So at the bottom of that mini map, you've got these quick links. So this is just how mine's currently configured, but if you were to change in that settings menu, that quick link section for the mini map, you could change which icons show up here as quickly accessible maps. By default, I believe this is pretty much the default view. I can't remember if I customized it much or not, but right now I've got the RDPS, which is the kind of the standard Canadian model map for clouds. The cloud ensemble map, which shows 3 different cloud covers in one view. The NBM, which is a blended map. It's a single map that blends a bunch of different models together. And then there's a transparency view, a seeing view, smoke view, a satellite view, which shows you the clouds at the moment from a GOES satellite, and then a light pollution view. And then there's layers where you can actually get to all the other sub layers that are in there, even if they're not quick links. Now the full map view, if you click anywhere inside this map, it'll pop up, as long as you don't click on one of the actual icons or the stars here, it's going to pop up the full map view. And within that, you've got other information. So you get a bigger view, obviously, and you can pinch in, zoom in and out, or you can also zoom with the plus and minus buttons over here. So if you wanted to zoom out further to see, okay, where is the cloud front? How far away is it? You know, that kind of stuff. You can zoom with that. And then the top shows whether it's whether you want the base map that's underneath the cloud information layers to be a terrain map, a satellite map, or a dark map. I tend to like the dark map. It's a good contrast, but you can select them as you prefer. And on if you want to change the location or center it on your current GPS or show or hide your favorites from the map, that's what these 3 buttons on the left do. On the right, you've got 3 different options for sky data to view. So this will actually change what map you're seeing, what overlay on top of the map you're going to be looking at. So this is their icon for cloud cover, this is their icon for transparency, and this is their icon for seeing. And within those, you might have other types of maps that represent different cloud cover models, which we'll look at in a minute too. Down the side here, you've got different ground data maps of information that you can look at. That's jet stream model, the air mass model, the GOES geocolor, that's like the current satellite view model, and then the light pollution map. The light pollution map is not going to change in real time. That's not like, oh, people turned on their porch lights and now it's not as nice over in this spot. So just be aware that's more of a static map from a light pollution survey from a couple years ago. And then down on the bottom, you'll see a few information here for the forecast timeline. So if you can see here, there's a play button and a back and forward. That will actually advance or move back by an hour the model that you're seeing. So if you hit play, it'll just cycle through the model over the next several hours that it has data for. Or you can go one by one, or you can grab the slider and slide it back and forth to where you want to see. But as that moves, the current view info is going to change to show what hour or what day that model represents. And then you can also, if you do move the map around, you can tap and drag to recenter this reticle if you wanted to a different location. And if you hit get new forecast, that'll update for that specific location. But now within that, we're just looking currently at the RDPS model, but there's also other forecasts that are cloud cover type forecasts, and you can see the whole list of them by clicking on the RDPS button, drop down menu there. So this is the full set of cloud cover forecasts that are available. These are all different types of cloud models that you can view. The RDPS, like I said, that's the standard one. The ensemble, like I said, that's 3 different cloud models shown in different colors in one. We'll look at that in a bit. There's an hourly one, so that gives you maybe a little more precise data, but it's not as large of an area. It doesn't forecast out as far, if I recall. And then our GFS clouds and a long-range cloud forecast. For the transparency forecast, you've got general transparency like humidity and dust and stuff in the air, and then one specific to smoke. And the smoke one's been particularly useful for us because we have been getting lots of those forest fires over in the West Coast or up in Canada. And believe it or not, they stretch all the way, several thousand miles away and find their way to our air neck of the woods over here. And we get some pretty bad smoke in the sky at times that can, depending on the moon situation, that kind of stuff can actually really block out a lot of what you're trying to see in the sky. When we had really bad, the worst smoke rating that they have, which is this purple color, with a full moon locally and we didn't vent, we couldn't see more than a handful of stars in the sky. Now, when it was that bad and I was up in the Adirondacks and there were a new moon, it was noticeably not particularly great transparency, but it didn't block out the stars to be a useless night the way it did when it was a full moon. So, and then the air mass forecasts, these are like ground forecasts essentially. So you've got temperature, you've got a dew point depression map, a wind map, and a surface pressure map. So you can see here, there's 3 different models that are selected now. There's the RDPS model on the left, the NAM model in the middle, and the GFS model on the right. Each of those is going to be represented in the ensemble map by a different color. And the overlapping those colors ends up making this cloud ensemble map. So this gives you an idea of the key, the legend is down in the left here. And you'll see that, if it's blue, that means RDPS thinks it's going to be cloudy there. So areas like this. But the other 2 models don't necessarily think it'll be cloudy there at that time. If it's red, GFS thinks it'll be cloudy, but not the other 2. If it's green, the NEM model thinks it will be cloudy, but not the other 2. And then you can see how in between them, there's yellow if NAM and GFS agree, pink if RDPS and GFS agree, but not NAM. If they all agree, it's going to be white. So they all basically agree that down this kind of center line here, you're going to have clouds, pretty substantial clouds. And if you look at the individual maps, you can see they've all got a fairly dark white or solid white, I guess is a better way to say it, representation of the cloud layer there. But when you look over at over the Great Lakes area, you can see that this RDPS map doesn't really think they're getting many clouds in the Great Lakes area, nor does this GFS map, but NAM does. And that's why when you look over here, NAM being green, you're seeing only green. And you can see that it's not a solid green, just like it's not solid white on the NAM map, which just implies it's not going to be 100% cloud cover in that location. But that model is predicting there's going to be some level of cloud cover, maybe a 20 or 30% or something, based on how different that is from their solid white areas. So the forecasting, now if we go back under that mini map on the main screen on the application, that forecast actually slides out to the right. You can scroll to the right in that view and see out about 3 days worth of time. And there's a lot of information in there. So first you can see, first obviously the time across the top and the date. The white bar represents the date change. So this is 11 p.m. on Saturday, 12 a.m. on Sunday. When you have the Pro model, you're going to see these multiple lines here, these individual bars within the actual cloud level bar. Those represent the different models, indication of what they think are going to be clouds in that look at that time. The transparency for that particular time and the seeing for that particular time are represented by the next 2 rows. If you have the Aurora KP values turned on, that'll show the KP index for the aurora likelihood, or the energy from from solar winds, essentially, that's going to be projected to hit the Earth at those particular hours. That can be helpful for trying to predict auroras, but there's actually another section in the application we'll look at later that is just added recently that has even more information about aurora prediction. You've got this sun and moon kind of setting pattern here. So the yellow, solid yellow, means the sun is up, and then as it goes down below the horizon, which is where the dark bar meets the light gray bar, it goes to a dashed line. That means the sun's down at that point. And at each of those crossings, you'll see that it shows the sun setting time at 6:52. The moon rising time, which is the white one, now goes solid at 8:45. Then there's also a representation just below the horizon within those of the astronomical twilight level. So when the sun goes down past that astronomical twilight level, then it's completely over the horizon of the Earth and not polluting your sky with the sunlight, essentially. You've also got these ISS icons that represent ISS passes overhead. This is, again, all localized to wherever you did your forecast from. When you click on them, which we'll look at in a bit, it'll actually show you information about that pass. And then this green line we'll talk about later too. This is one that I added. You can have, I think, up to 3 lines added for different targets in the sky, deep space objects, to represent their rising and setting time in the sky on this same chart here. Below that, even more information. You've got the wind, which includes the direction. And also, one thing I didn't mention, the color coding for these rows up here, the darker the blue, the better. So if it's a cloud forecast row, then the dark blue means, like over here around Sunday at 11, very little, if any, clouds in the sky. But if it's going to be white, then it's going to be, pretty much solid clouds. So you can see that the models disagree at different points to some extent as to, where the clouds are going to be. But that if they're all blue throughout, then it's going to look like just a solid single, rectangle there. That means they all agree. Whatever color it might be, they're going to agree. If they're all the same color, it's going to blend in. The same thing goes for the wind in terms of the color. The darker the blue represents like 0 miles per hour of wind. The closer it is to white, like over here, it's not white necessarily, but it's a lighter blue. That indicates it's going to be a higher wind. And then the little arrow is like a windsock pointing at the direction of the wind. So all those come into play when you're trying to figure out, do I want to go out? Is it a good time to go out and go, stargazing? If there's clouds, obviously you're not going to want to go. If there's transparency issues, you're not going to see much. If there's seeing issues, you'll have a hard time seeing fine details, like planetary imaging would not be good on a poor seeing night in particular. If it's windy, you're not going to want to go out because your tripod's not going to be steady. So all those things kind of come into play. And then the last 2 down here are the temperature and the dew point. So you can get an idea for how cold it's going to be, and am I going to have to worry about dew building up on my telescope or bring my dew heaters with to try and combat that. The other bar that's not on that last view, when you this blue line represents the actual time that it is when you're looking at the map. So when I took this screenshot of the application, it was 3:02 a.m. And so it drew that thin blue line to show me where on this chart is now. And then when you click on a row, or sorry, on a column, then it highlights that particular column. So it makes it easier to see all the information for that specific time. And when I say click, I mean, tap on your phone. So here I tapped on the 9 a.m. position or column for Sunday. And it just makes it easier to follow that down and see which winds and temperature and dew points align with that information. Now, on top of that, right below this chart view is more specific information about those same data points. So here at 9, where I selected, whatever column you select, it's going to update the information here at the bottom. So this is specific for the 9 p.m. window. So it's showing that of the 4 models for cloud cover, one thinks 37%, one thinks 16%, one thinks 94%, and one thinks 0% cloud cover. So it's a pretty wide range. So there's probably a lot of, cloud mass or air masses combining. Maybe we had hurricane or something going on that showed up that day. It made it very variable and tough to predict. But then you can also see the wind is 2 miles an hour. It's a fairly dark blue circle there. So that's going to be, pretty low mileage of wind, which is good. But the transparency, it's saying, you're not going to have good transparency. It's going to be cloudy, and the seeing is going to be poor. So that wouldn't be a particularly good time to try and do much. So just zooming in here, just to kind of show a little more clearly those individual bars that show up in that when you have the pro level in the cloud layer. And I'll show later too, this is the transparency layer. If you have the smoke one enabled, it'll actually show the smoke color, very similar to a little rectangle like that, but with a smoke color legend through the transparency bar. So which models are those of those little slivers that are in there? Well, the RDPS, like I said, that's the free level forecast model that you get with the free version of the application. That's the overall large rectangle that's in that row. Then in front of that, you've got the NBM model, NAM model, and GFS model. So from the documentation here, we can see that the NBM model is one that's a national blended model. So it's a 1 hour frequency update, which is nice. Usually that makes it a little more accurate because you're not waiting. You're more up to date on the information. And the NBM model also is kind of unique because it actually blends over 40 different models into the single outlook. And it updates every hour, like I mentioned, and it forecasts out for 3 days. And that's a higher resolution grid size that it uses. So this is looking at data accurate to your location within 2.5 square kilometers, whereas the RDPS model for the free version is looking at a 10 kilometers square area. So in theory, the NBM model should be, generally speaking, more accurate, especially as you get closer to a time. If you're getting ready to go out that night, 6 hours before, the data you might be looking at from the other models might be 6 hours old, but you might have just refreshed the NBM data. And where you can tell how when you were last refreshed, at the very bottom of the full app window, if you scroll all the way to the bottom, one of those panels there, those information panels with the forecast details, and again, it's showing you your longitude and latitude, but it's showing you the different models data that it's loading, and it shows you when it loaded it, and if that location has model data at all. Because if you go somewhere in Canada, there's areas and stuff that are not covered by all of the models, for instance. Most of the US is covered by all of them, but there might be places just outside that are not completely covered by the model, so you wouldn't have a check mark there if the model didn't apply for them. And then it tells you when the next one's coming. So at this time, it was like you saw before, it was 3:02 a.m. when I was looking at that chart that I took the screenshot of. Then it got updated at 3:08 a.m. For the NBM model. So that was 3 hour newer data than any of the other models were going to present to me. So if I was thinking about going outside at that moment, the NBM model is probably going to have more accurate data for me. Now the smoke, like I mentioned, if you have the pro level, those smoke bars show up just like the cloud ones do, only it's going to use the smoke legend for the coloring. So purple is the densest smoke, and we get to the green, that's kind of the lighter smoke. Once it's blue or white, you tend to not, I don't think it even shows it in the view. It's kind of inconsequential at that level. But the default, these ones have multiple models for the clouds, but the default models for both the transparency and the seeing comes from the RDPS or the RDPS plus NOAA map models. So that's not using the 6 different models or whatever for the other cloud layers. So I mentioned the ISS transits. So the icon that we see there, the little ISS icon, it stands out pretty well. If you tap on those, then you get, where'd it go? Oh, they're there. Okay. So if you tap on those, you can see here that it shows the arc that the ISS is going to be following. And the way you read this would be like holding your phone up to your zenith, straight up. And you can find Polaris or north while you're pointing straight up, face the north on this chart towards north on the Earth, and that'll align you in the right direction. This little green arrow is when it's going to become visible. So it was already, in this case, it was probably already visible just over the horizon. So for you at this particular time and location, it's going to be visible once it comes over the horizon. And then as this fades out, the yellow represents the maximum altitude. So that's going to be the highest point in the sky. In this case, it's not getting particularly high. Zenith would be straight above you, right? And then at the very end, you'll see that the white line turns into a very faint, thin line. And that's where it actually hits the Earth's shadow. So you'll stop being able to see it at that point. So this is all represented on here in the actual numbers as well. So in this case, it was going to rise at 721 in the northwest. I was going to hit the max altitude at 726. And it was going to enter the shadow at 729. And you can also see that there's a difference in the colors of the backgrounds here. So this was 7:26 p.m. At that time of that day, the sun was still setting. So the sun was still offering some light pollution into our night sky. And that was kind of what this yellowness is representing from the west side. And the other one here, the moon was actually, I forget if it was setting or starting to come up, but that was, well, it was in the east, so it was coming up at that point around 9 p.m. And so there's actually going to be some moon glow kind of getting in the way a little bit, not a perfectly dark sky at that particular moment. But you can see how this one, the yellow max altitude is 901. It's also going to enter a shadow at 901. So it's a much shorter arc that you're going to be able to follow it for, although it is getting just slightly higher in altitude than the other one did. So extended cloud forecast. So this is below that information for the specific values that were shown for the wind speeds and the temperature, etc., based on the hour that you selected in the map, in the chart view. So just below that's this extended cloud forecast. So these are, taken with a grain of salt. The cloud forecasting, particularly in the Northeast, is really difficult because we do have a lot of different types of air masses that tend to collide over us. And so anything further out than almost 2 days is almost hard to really rely on too much, unless you see a very long run of the exact same type of forecast. So if I saw 3 or 4 days straight of just dark blue, kind of like you see 3 or 4 days straight of white here, I would say, okay, I'm not going to really bother looking at Wednesday in the next couple of days, because most likely there's some big cloud mass here. There's probably rain or something like that predicted. I think this might have been when the hurricane was around. The Helene might have been around this time frame. I forget. So it's going to likely, it's not usually off in the grand scheme like that. But I wouldn't necessarily say, okay, it looks like it might be a little bit blue on Monday, a week out from now, after 11 p.m. So maybe I'll make some plans. Like this type of prediction is probably going to change quite a bit by the time Monday rolls around. But it is there to give you some idea and guessing at how it's going to be, so you can at least keep an eye out. But you have some of the other similar information for the sunset times and moon set and rise times, as well as the dark sky object that I focused on, set and rise time, and then the KP index as well. So as I mentioned before, at the top of the mini map view, you see what location you're currently getting a forecast for. You click on that magnifying glass, it's going to pop up a search bar, and you can type into that either a name, so in this case I did SUNY New Paltz, or you can do like a town name, stuff like that. And then once you find the one you want, and if it came up right, then you could say get the forecast for that particular spot. If you needed to, you could recenter it on the GPS and just, you could center on GPS is going to use your GPS location basically. But once it's on the map here too, you can also just move it around if it was off by a little bit. If maybe I was looking for something by name, I knew it was next to New Paltz, but didn't remember the name of it, or the name didn't get found when I searched on it. You could go to, you could hit refine on map, and then kind of dial it in, and then hit tell to get the forecast then. But once it's loaded, and if you want to add that as a favorite, so you don't have to search it every time, then you've got it loaded up here. You click on the star in the corner, and that's going to pop up here with the favorite window. You give it a location name and hit save, and then it's going to put it into your favorites list like this. The favorites list, you can see, gives you a high-level view of the cloud model forecast for those different, for the next few days. I think it's the extended forecast view. So you can get an idea of where it might be, less cloudy. You can also see that this yellow one means I have an alert defined. We'll talk about that next. So it'll actually give me pop-up notifications on my phone when certain criteria are met. And these other three, I don't have alerts set for them. And then you can share them also if you want to send them to a friend, for a location. So the alerts is a nice little feature. As a demonstration, I'm going to add an alert here to the Lake Taconic State Park favorite that I have. Click on the gray bell, and then you can choose enable weather alerts. This also gives you the option for creating a signature, which would be like the code you would add to a web page that would show the forecast information for that location specifically. So most probably won't use that for most people, but If we click on enable weather alerts, then it's going to ask you to click once more to enable the alerts for that particular location. And then it gives you all the options that you can set for what type of data you want to hone in on. What do you care about? So it does have a couple presets that it defines as just general clear skies or planetary observing versus deep sky observing. But you can move all the sliders and dial them in exactly how you want them to be. So you can say, don't alert me unless the forecast is the way I want it to be for at least 2 hours, because I don't want to, for me, that's a 45-minute drive. I'm not going to drive up there for a half hour of good sky. So I want there to be at least 2 hours of good sky if I'm going to bother going up there. You can choose where in the sky the sun needs to be. And you can see there's a couple of quick options too for each of the individual settings. So if you wanted to tell it, just night, it'll move that slider to what, night, which will be probably a little past zero, what's a little below 0 degrees in the horizon. You can say, tell me when the moon is only 50% or less illuminated. How much cloud cover are you okay with? What kind of transparency level you want it to be seeing, the temperature, the dew point, wind speeds, and then also KP index. If the aurora viewing is an important factor for you, you can tell it to alert you when the KP index is at a certain number, along with the cloud cover being at a certain number. So once you set those, if you want to disable it, there's a big red disable button. But otherwise, if you go back, it'll save those settings and generate alerts, notifications on your phone next time it meets those criteria. And you'll also see that the bell now will be yellow, indicating that it there is an alert enabled. Now, when you get an alert and you come back into your application and you go into your favorites view, you'll see that the location that has the alerted window of time is kind of highlighted with this blue edging. And then on the actual chart view, you'll see that particular window of time is highlighted with the same kind of blue glow as well. So you can see it was real nice skies that particular night. Seeing that's like an average seeing and an average transparency, which for the Northeast is kind of almost the best you can ask for 9 times out of 10. So this was telling me, hey, I got a bunch of hours here where I could potentially go get some good viewing in because the skies are looking nice and met my criteria. So there's a moon details panel as you scroll down on the main view. Gives you all the information you could possibly want. You get the current phase based on whatever hour you selected in the chart up top, and how much illuminated it was. It gives you the next phases dates, and it gives you information about the total lunar eclipse, the next one that's coming up for that location, which apparently is March 14th of 2025. And it also has information about solar eclipses, but I can't bring that up as a demonstration because I didn't look to find where there was going to be a solar eclipse and load that forecast for you. But it shows very similar information about, it shows, in this case, the prenumbral phase, the partial eclipse phase, and total. It's showing when they're going to start. And then it shows that as a part of the chart here. So you get an idea of, what time each of the phases of that eclipse is going to happen. So that does the same thing for solar eclipses as well. So now you got the charting, the astronomical clock, which is the next panel. So this is kind of a complicated looking panel, but basically you've got the 24 hours in a radius here, from noon at the bottom to midnight at the top, and the colors represent kind of the phases of darkness. So you've got the golden hour of the sunset, and then by the time you're up here, you've got to the point where the sun's completely out of the way and no longer impacting your night sky at about, looks like about 8:10 or 8:15 or so right there. If you look here, there's a legend for what these lines all represent. Well, the red line represents your current time. So it was 3:53 a.m. when I took that screenshot. And then these arced lines represent the different targets of interest mapped as their rise and set times on this astronomical clock. So in this case, the yellow line here is Jupiter. The green one is one that I added, which is Andromeda Galaxy, and I'll show you how I add that in a second. So that's the green one here. And this is the green line that we saw earlier on the chart as well, showing the set and rise times and peaks. The moon is going to be the white arc, And then down here, you've got the Comet C 2023, which is the current one that everybody's interested in. Shows when that's going to be rising and setting. And then the Eagle Nebula. So the Eagle Nebula, again, one that you can set as like a custom. So it's this blue teal kind of color here. It gives you the actual times down here as well, but you can kind of visualize if you're trying to plan what you want to image. You can see, are the targets that you're interested in imaging, are they both up at the same time, or do they line up where you might switch from one to the other as one's setting and the other one's coming up, that kind of thing. And you can move the slider around to kind of see how it all adjusts over time as well. So when you click on the My List Edit button in the bottom left, then that shows you your list of custom targets. You can remove or add them, and then you can choose up to four, these four in the topmost position here, to actually whether or not you want them to be added on that forecast view, which was higher up on the main panel that showed the ISS passes and all that kind of stuff up here. You don't have to have them up there. So I didn't, for instance, I showed you how the Andromeda Galaxy was visible, but there was no blue, teal or whatever color that is, turquoise kind of blue line on that other chart for the Eagle Nebula. It's only in my astronomical clock view. And you can change the colors and that kind of stuff, or you can remove them. There's quick links for the solar system ones to add those. Popular objects, it gives you a couple that are popular this month in case you're curious to add those. A couple popular comets. So there's 2 here, and then the list continues to these other 5 or 6 here. And then you can also search on different objects. Now the comet ones, I don't think you can search on comets. I think because it's only going to search the Messier, NGC, IC, and Able catalogs. So the comets that you're going to get to choose from are just going to be probably the brightest, 5 or 10 that it's keeping track of in the background on, that Astrospheric puts in there and to be able to click on, as opposed to being able to search for them themselves individually. So if you had some obscure comet you're trying to find, you may not have that in the list. And then you can also manually enter RA and DEC information if it's not finding, if it's in some other catalog, but it's an object that's not a comet, it's not moving around. You can put in the right ascension and declination information and add it manually that way. Oh, there we go. Now, if you click on the planets button in the corner, that'll change the view and show just the planets. So you get the same, the same type of view in terms of it being that astronomical clock view, but it's gonna not show your custom stuff or your deep sky stuff. It's just gonna show your planets. So depending on what you're interested in seeing, you can customize that how you like. So the Aurora Borealis forecast, this is brand new, just added at the end of September. In fact, I thought I was done with my slides and had to add this because they added a new feature after I was done with the slides. So it shows the current solar activity related to the aurora and can play an animating projection of the upcoming aurora if you hit the play button here. Only forecast forward about an hour, and that's just because the NOAA data is pretty short in terms of its forecast as well. So that's all there is to look at it. There's not a lot of multi-day type data that's very accurate. The green dot that's on the globe here is representing your location. You can move the globe around if you kind of tap and drag your finger around a little bit, but generally it gives you kind of sort of that top-down view so you can see the aurora haze kind of area for the projection more easily. It's showing you basically how close it's getting to your location and whether or not it might be over you or at least visible from your location. And then it gives you 3 data points at the bottom to sort of justify that as well. The speed and the density indicate the speed and the density of the like the coronal mass ejection, the actual solar wind that's coming and hitting Earth. It's the energized particles that are hitting us that interact with our atmosphere's elements to cause the aurora. So obviously higher speed and higher density is going to increase your likelihood of brightness and seeing it at all. The last one, the BZ, is basically relative to the Earth's magnetic field strength in the northern hemisphere. So that one actually you want to be lower. So the lower it is, the more likely you're going to see it, because it's sort of like that magnetic resistance is less, and so it's allowing more of the particles to actually reach the Earth's atmosphere and interact with our lower atmosphere. So we look at what it looked like just this past couple days ago on the 11th. As you may have seen, some people around, you may have noticed your Facebook feed filled with images of the aurora. You can see how much dark red. It was basically 100% chance you're going to see aurora in that entire band of area, and you can see it easily covered the southern New York area that we're in with this purple bluish kind of down towards this like 20% kind of range of color zone. But you can see that the density was much higher. Actually, if we go back, you'll see that the scale actually changed. So density here was 0 to 20, and the BZ was the white line 0 with a high of 5 and a low of 10, negative 10. And we go down here, this is over 20 at the peak. This was around 6 p.m. The BZ index now is ranging from upper almost 20 to negative 60. So the magnetic field strength dropped quite a lot there. Also the speed, we go back, it was averaging 3 to 350, and the heavy day that we saw the aurora, it was well over 700, almost 800 at points, and then kind of dwindling from there. So this gives you some idea of how you can read this to look for the likelihood of auroras. Now the other way to look for the likelihood of auroras is lately your newsfeed will light up. So they're paying attention to this information too. But this is how you can kind of get an idea for yourself. If you don't have to trust a national news source. This is localized information. And then this was what it looked like that night from the 11th when I was going over to New Paltz. So it was pretty spot on with being able to see the aurora. So the last panel in the main view there is the site mode link, and that'll show you GPS details like your coordinates and your altitude. So it's in red because it's sort of like useful for people that have maybe a go-to telescope and are looking to enter that information when they're setting up for polar alignment or trying to align north, that kind of thing. Just gives you the basic information you would normally punch into your computerized telescope to make that work nicely, and it's accurate to wherever you're currently at based on your GPS. So managed to get all the slides in with 5 minutes left before 9. I do have to leave on time today because I have to pick my wife up at the airport, about an hour and a half away, but I do have some time for some questions if anybody has any. See somebody coming up to the podium there.
Hey, Steve, I got one.
Yep.
I have my phone here. I don't know where the favorites is on here, but when you're on the main,
if you're on the main
Yeah.
view,
the star up next to the S. Right?
yep. So,
Okay. Your list of favorites showed a brief synopsis of the bars, the blue to white bars. Mine does not, and also on the home thing, the desktop, your sidebar has those, the favorites with a brief, right there. I see it, home.
Oops.
MHAA.
Going the wrong way. Yep.
Yeah.
Clicking too many buttons. There you go.
Yeah, so those it has the blue and white squares for each hour.
Yep.
Mine does not have that. It's just a gray bar.
Okay. Do you have the Pro or do you have our Pro Society edition?
Yeah, the Pro, right.
You do. Okay, that's interesting. I don't remember it. Well, I guess check in the
Yeah, you got it.
little config wheel button there. Does that have any options for showing that maybe?
Okay, thanks.
Yeah, I've got it, so maybe I can help him with that when we get at dinner.
Okay. Yeah. I don't remember having to enable anything specifically to do that, but I've had this for a couple of years now, so it's possible that I did at some point.
Mine has it too,
Okay.
but it could be that you're not logged in.
Maybe. Yeah, if you go back to the main screen, does it say log in or sign in at that top right corner? Let me go back.
So we're looking at the phones, but
Yep.
another problem, something that annoys me
Yep.
is on the desktop is that when I refresh my, when I update my browser, it forgets me and I have to go through the login again. And it's not by a password, it's by typing.
Yes,
your
by email. Yeah.
We'll
Yeah.
send you a code. And Google and Edge keep like offering updates every week. Knock it off, guys.
That's interesting. I don't know. I mean, I don't use the website very often, so I guess I can't say if I've experienced the same issue. I guess I mean, I believe you, but I'm thinking that must be that it's clearing out the.
On,
yeah.
Every couple of days, and on mobile it doesn't do that. But I'm wondering if Scott might have somehow accidentally got bounced out and needs to log in again.
Maybe. Yeah. Yeah. I would look in that upper right corner. If it shows sign in, then you're not currently, it's not going to load your, although you wouldn't see your favorites at all, I think, if you're not logged in there.
Yeah, we'll play with it. Look, anybody else got a question in the room? Since you got 2 minutes left.
Just a quick one. If you're actually at a site observing and clouds move in, how accurate is this? Like, as far as predicting, you pull up the app on your phone and look, and it says, oh, it's going to clear again in such and such time. How accurate is that? Is that?
We've had pretty decent luck with that when we were using, we would see that at Lake Taconic in the past at a couple of the star parties and be like, okay, yeah, it looks like it might be kind of good when we start, kind of crappy from like 8 to 9, but then it's going to clear up again. That's usually been pretty accurate. It's been, a fairly accurate prediction from what we've seen, being only, an hour or 2 hours or 3 hours out or something like that. But I mean, yeah, I was trying to, it's hard to come up with the exact example what which star party it was, but I know we've had that exact type of situation before and had it dialed in just like the prediction indicated it would.
Yeah, since you're short on time, are there any questions on the in the Zoom room?
Quick question. You said really early in the talk that rather than try and log in and then request a key, you wanted to send us a key in advance.
Yep.
So how do we do that? So
you can either ping me on Slack, or you can message me, with an email, steve@midhudsonastro.org, like that. Or what I probably can do actually too is we could create a page. There's ways for us to create links off of our member accounts. I was thinking about this earlier today. And so we could add a link off the member account that would take you to the page that's guarded to only active members on the website that would have the code. We could do something like that.
Okay, well,
but for the time being, because I got to make that.
I think I'll go on Slack and request a key.
Yeah, just ping me on Slack or send me an email and I'll send you the code for it. Yep.
Perfect.
Steve, you're out of time. Do you want to take any more?
I could take 1 or 2 more if anybody's got a question.
In the Slack room, anybody?
No,
I can't see the
thanks, Steve.
chat. So. Oh, wait, there's the chat. Is there anybody in there? Welcome, fellow cheesehead. Hi, Steve.
Howdy.
All Steves come from cheese, right?
All the Steves come from Wisconsin.
All right.
All right. Anybody else have a question?
Dynamite.
Okay, good.
Yeah, you actually cleared up a few things for me. All right, Steve, thank you so much. I don't want to hold
No
you
problem.
up any
Yeah, sorry I
longer.
have to run so I can join you for pizza, but next time.
Yeah, that's maybe we can work out a few of the issues at Pasquale's.
Yeah, if anybody has any particular issues, even after trying to work with Jack this evening, feel free to message me or send me an email and tell me what you're running into, and I'll do what I can to help you out.
Yeah, I'll post the Slack.
Thank you.
Lovely. All right, Steve, thank you so much, man.